to S classes. In this video, we will study about steady state error analysis for the unit ramp function. Okay, let's start on class. Steady state error means the error which is occur when the time is infinity. In frequency domain, we have studied it that the error occur when S tends to 0. The basic formula for steady state error is ESS is equal to limit S tends to 0 S into E of S. This is the basic formula for steady state error. Here what is E of S? We know that E of S is equal to R of S divided by 1 plus G of S into H of S. This is the main formula for error, and this one is the formula for steady state error. When the error into S, when time tends to infinity and S tends to 0. Now here the input is unit ramp input. Last class we have studied the input was unit step function. So t is equal to 1. So here R of t is equal to t, which is equal to unit function u of t. It is a unit ramp function, so R of t is equal to u of t is equal to t here. So we have to find what is R of S. R of S is the Laplace transformation of R of t, which is equal to Laplace transformation of u of t is equal to Laplace of t is equal to 1 by S square. That implies R of S is equal to 1 by S square. I will put the value of R of S in this equation. So E of S will be 1 by S square divided by 1 plus G of S into H of S. Here I found the value of E of S. I have to put this value in steady state error, that is E of S formula. So E of S SS is equal to limit S tends to 0. Here the value was S into E of S, and E of S I have got here. So S into 1 by S square divided by 1 plus G of S into H of S. Here S into 1 by S is equal to 1 by S. So this value will be limit S tends to 0 1 divided by S whole into 1 plus G of S into H of S. If I put simplification here, then the value will be limit S tends to 0 1 divided by S plus S into G of S into H of S. If the limit S tends to 0 taken to inside, then its value will be limit S tends to 0 1 divided by limit S tends to 0 S plus limit S tends to 0 S into G of S into H of S, which is equal to 1 divided by 0 plus limit S tends to 0 S into G of S into H of S. Here I see that 1 divided by limit S tends to 0 S into G of S into H of S. In the last class I have studied limit S tends to 0 S into G of S H of S. This is the formula for KB. So here the value is 1 by KB, which is the ESS for unit ramp input. The value of ESS is equal to 1 divided by limit S tends to 0 S into G of S into H of S, which is the value of KB. So the value of ESS is purely dependent upon G of S into H of S. And in the previous class we have studied the value of G of S into H of S is equal to K into S minus Z1 into S minus Z2 S minus Z3 similar divided by S to the power n into s minus p1, s minus p2, s minus p3 and so on. This is the formula for g of s into h of s. The value of ESS is purely depend upon this formula, and this formula one thing is varying, that is s power n. So depending on the value of n, the type of the error changes. N is the type of the system. If n is equal to 0, that implies the value of gs into hs, g of s into h of s is equal to constant into s minus z1, s minus z2, so on, divided by s power n. N value is 0. So s power 0 into s minus z1 into s minus z2, so on. Here s power 0 is equal to 1. So all these parts will be constant k. G of s into h of s is equal to k. But the value of limit s tends to 0, s into g of s into h of s is equal to limit s tends to 0, 0. That implies 0 into constant is equal to 0. And the value of ESS will be ESS is equal to 1 divided by limit s tends to 0, s into g of s into h of s, which is equal to 1 divided by 0. That implies this value is infinity. This is for type 0. If it is type 1, for type 1 system, n is equal to 1 here. So g of s into h of s is equal to k into s minus z1, s minus z2 divided by s power of 1, s minus p1 into s minus p2 and so on, which is equal to now we'll put this in the equation ESS. ESS is equal to 1 divided by limit s tends to 0, s into this value k into s minus z1, s minus z2 divided by s power 1 into s minus p1, so on. S and s will be cancelled out. So this part is a constant part, and one by constant is equal to another constant. So here for type 1 system, the error in the steady state is constant. Now we'll go for type 2 system. In type 2 system, n is equal to 2. By putting the value of 2 here, we can get g of s into h of s is equal to k into s minus z1 into s minus z2 into s minus z3 divided by s square into s minus p1 into s minus p2, s minus p3 and so on. If we put this value in the ESS formula, so ESS is equal to 1 divided by limit s tends to 0, s into k into s minus z1 into s minus z2 divided by s square into s minus p1 into s minus p2 and so on. Here s and s square, so 1 by s will be here. 1 by s means it is infinity. So ESS will be 1 divided by this value will be infinity. So 1 by infinity is equal to 0. That means error in the steady state for the type 2 it is 0 here. In this class we have studied the error analysis for unit ramp impulse function when it is type 0, type 1 and type 2 function. In the next class we will study about the error analysis for the steady state when the input is parabolic function. Thank you.